Hey guys, today we are going to learn how to write recursive formulas for geometric sequences. And a geometric sequence is a sequence where the ratio of consecutive terms is a constant, which we're going to call R, and that R's title is going to be the common ratio. So in the units previous to this, we learned how to do arithmetic sequences. And arithmetic sequences, they use addition or subtraction to move from one number to the next, where the difference that we're doing now, instead of adding and subtracting one number to the next, we're going to be multiplying by something to move from the first term to the second term. We're going to talk about recursive sequences today. And since our I can statement is to write those recursive formulas, we need to know what the formula is. And since we're dealing with the previous term, a recursive rule is a rule that's definition is based on that previous term. So our formula is telling us what is that first term value. So that first term is going to be signified by G sub 1. The 1 just means it's the first term, and G just means it's a geometric sequence. Now, the rest of your formula is everything I highlighted in yellow here. That's your formula part. G sub n is equal to your common ratio, which is your R value, times G sub n minus 1. Remember, that's a fancy way of saying the previous term. So let's write down next to this everything that all of these letters mean just one more time so we have a place to look for it really quick and easy. All right, the first thing that we're going to talk about is G sub 1, and that's your first term. G sub 1 is your first term. You also need to know the R value, and that's your common ratio. And I'm going to talk in a minute how to find the common ratio. I'm going to give you a way to remember it. And then the other letters in this is your G sub n, and that is your nth term. And you write that in the front of your rule because that's like your vague way of giving the formula. And then the last one is this fancy Nancy way of saying the previous term. So it's G sub n minus 1. And all that fancy way is saying is previous term. All right, so now we're going to talk about a bungee jumper that jumps from a bridge. The table displays part of the sequence that models the bungee jumper's maximum height in feet above the water during each rebound. So if you're given this, the first rebound, so he goes down and then he comes back up. So this is the first rebound. So number of rebounds is 1, and that height is 200. Then he goes down again, and then he comes back up. That height is 80, and that's the second rebound, so 280. And then the last one is the third rebound that we have information for is 30 and then 32 feet. Okay, so the question is asking right here, it's asking, is this sequence arithmetic or geometric? And so let's talk about arithmetic. Arithmetic, remember, means you're adding or subtracting something each time. So if I take 200 and I subtract a number from 200 to get to 80, that would be subtracting 120. If I do that, if it's an arithmetic sequence, then you have to have the same thing happen. So 80 minus 120 would have to give me this third number. And that 80 minus 120 is a negative number. It's a negative 40, and that's definitely not 32. So this is not arithmetic. So let's look at geometric. Geometric means that it's going to multiply from one number to the next. And we're going to figure that out in a second. But the reason it's not arithmetic is because you're not subtracting the same amount every time. It's geometric, not arithmetic, because you're not subtracting the same amount every time. Now, find the common ratio. This is what I was talking about a while ago. In order to find the common ratio, you're always going to take the second term, which was 80, and you're going to divide it by the first term, which is 200. If you always do it this way, you're going to get if you type it in Desmos, you're going to get a decimal. 80 divided by 200 is 0.4. I don't want a decimal though. I want you to switch it over to a fraction. And when you're doing that, switching over process, all you have to do is push that little fraction bar in that circle, and that's going to give you the fraction 2/5. All right, so one more time, let me talk about this. The 80 came from the second term, so I can say that's G sub 2. That means the second term. Now, the first term, we already discussed how to notate the first term. That was G1, G sub 1. So I'm going to write G sub 1. So you can use this formula, per se, to find the common ratio every single time. Now, let's see if that actually works. If you take 200 and multiply it by 2/5, you should get 80. If you take 80 and multiply it by 2/5, you should get 32. So as I do this, 80 times 2/5, that is 32. So I am proving that it is geometric because it's multiplying by the same number each time. That number is your common ratio. It's also known as your R. All right. Now, it says, what are the fourth and fifth terms in the sequence? So if we keep going from 32, so it was 200, 80, 32. That was our third term. Then our fourth term and fifth term. That's what they're trying to get us to find. So if you take 32, and you multiply it by your common ratio, which was 2/5, that gives you 12.8. And then if you take 12.8 and multiply that by 2/5, 12.8 times 2/5, it gives you 5.12 right there. So that is my fourth and fifth terms. Now it says over here, part D, what is G sub 1? Remember, G sub 1 simply means the first term. That's what that 1 is signifying. So the first term in the sequence was 200. Now I want you to take note here. We have two colors. We have the first term, which was 200, and it came from the first term in our sequence. That was our first rebound. Then we have this information that we found in part B, which was the common ratio, which was 2/5. Now, to write the recursive rule for the sequence, you start out with G sub n equals. G sub n equals. My ratio, my common ratio was 2/5 times. Then it says to write the previous term, G sub n minus 1. Now I'm not finished. That's only one part, one line of the rule. You have to have two lines, and that second line is your G sub 1. You have to tell me what is my first term, and my first term is 200. Now on the word problems, although they look like word problems, it's actually breaking it down for you. So G sub 1 came from the information in part D. Your R value right here came from the information in part B. So I tried to color coordinate it so you actually see where all of those things are coming from. And then these two, they don't change because it's part of the formula. And remember, that's the nth term and that's the previous term. All right, so let's go ahead and turn the page over. And it says the following geometric sequence is shown on the graph below. So they're giving you the first term is 160. So in my sequence, I'm writing out 160 as my first term. My second term is 80. My third term is 40. My fourth term should be 20. And my fifth term is 5. My fifth term is 10. So anytime you're given a graph like this, go ahead and break it apart. Put your y values as your sequence. Now it says, what is the value of G sub 1? Now remember, G sub 1 means it's the first term. So your first term is 160 right there. That's our G1. then it says, what is the common ratio? So I want you to write over here, common ratio. We're going to write that formula real big so we can see it. All right, that common ratio is G2 divided by G1, and that's what's equal to R. Remember, G2 just means the second term, and G1 means the first term. So if you're looking at our sequence here, our second term was 80. And our first term, because remember that's G2, our first term was 160. Now, if you type 80 divided by 160 in Desmos, 80, if I can hit the 0, divided by 160, it gives me 0.5, but remember I said I wanted a fraction. So if you hit this little circle guy over here, it will change that automatically over into a fraction for you. So this is my R value, and that's equal to 1/2. Now to write the recursive rule for the sequence, remember that recursive rule was G1 is equal to a number, and then it was G sub n equals R times G sub n minus 1. And we just have to fill in these two spaces with whatever it was from the beginning. So my G1 was 160. That's what's going to go right here. My common ratio was 1/2. And that's what's going to go in my R place. So as I write this out, I have G1 is equal to 160. G sub n is equal to my common ratio as 1/2 times G sub n minus 1. So hopefully you can see with my highlighting, you can see exactly where everything is coming from. Now, why are the points not connected on the graph is the next question. Well, the 1, 2, 3, 4, 5, those are position numbers. If you're in a race, any kind of race that you want to be in, you can finish first place, you can finish fifth place, but you cannot finish place 1.5, 1.5. That's not an option for a position. So since these are position numbers, that is why you cannot have those dots connected. You can only have whole numbers. So what we're going to write here is there can only be whole numbers representing position numbers. Sorry, you couldn't see that. There can only be whole numbers representing position numbers. Now, it's asking, what is the term of the 8th position of the sequence? This is the bad part about this type of rule, the recursive rule, is you've got to list them all out. So again, I'm just going to write it again down here so I don't have to keep moving my paper up and down. But the first term was 160. The second term was 80. Third term was 40, then 20, and then 10. 10 was my 5th term. I'm trying to get to the 8th. So this is my 6th. Here's my 7th. Here's my 8th. This one is going to be my answer to this question. So as I do this, we found our common ratio to be 1/2. We multiplied 60 times 1/2 to get 80. Half of 80, remember of means to multiply, so 80 times 1/2 is 40. 40 times 1/2 is 20. 20 times 1/2 is 10. So if I take 10 and I take half of it, 10 times 1/2, that's 5. Then I take 5 times 1/2, and that's going to give me 2.5. And then I'm going to do it one last time. I'm going to take that number and multiply it by 1/2. 2.5 times half, that gives you 1.25. 5. So 1.25 is the eighth term. And how you can write that out is G sub 8 is equal to, that means it's the eighth position, 1.25. Okay, that finishes up the lesson for today. And now you'll be able to write recursive formulas for geometric sequences. You're going to have a worksheet that you complete today, and it'll be due tomorrow. Have a great day.